So the next sum is an IRR sum. So first we'll see the theory for IRR and then we'll start with the problem. So if you look here, the internal rate of return, that is what is IRR full form is. This rate of return is also referred to as expected return on particular project. Okay, it is something like profitability, but we should not say it is profitability there. The interest, okay, the interest rate, sorry, the internal rate of return is characterized by a discount rate that reduces the NPV to 0. Okay, so what is IRR? IRR is the point at which NPV becomes 0. Okay, so we'll work out it and we'll see how it works. The discount rate is therefore seen to be essential because its increase results in uncertainty in future cash flow, reducing the value of returns. So typically IRR is a percentage. Higher the IRR, the better the project is. Okay, so when there are like two projects having different IRRs, we have to select the one which has a higher IRR. So that's about the problem here. So let's work out the problem. So we'll start with this problem. We have the numbers, so we will just take the numbers and we'll use. So we have worked out So we have already worked out one part of the NPV and we got the answer also, right? We also got the answer, but we'll just like little bit refine it. So it's going to be the same numerical problem. An investment has 12,000 as the investment and 600 is the scrap value. The yields the following returns. Cash inflow for first year is 5,000, 4,000, 3,000, 2,000 and 2,000. Okay. The cost of capital is 10% and we have now going to find out the IRR. So we have already found out how to do an NPV. So for an IRR, the first concept is to first get the an answer for NPV. Okay, even if you are going to do an IRR problem, you have to first do the NPV. Okay, at least once you have to do the NPV. So if you look at here, the NPV we are doing with a discount factor of 10%, which is given actually in the sum. If you do this, you will get an answer. Okay, if you do this, you will get an NPV answer. So the concept here thereafter becomes if the NPV is positive, then again compute NPV with a higher discount factor. Okay, if the NPV is positive, you have to use a higher discount factor. So assume that if it's going to be negative, then what should we do? Right, so that is again a question. If the NPV is negative, then again compute NPV with lower discount factor. Okay, so these are the steps for IRR. So these are like very important steps, so you have to note them. Okay, you have to note them. So we have already done an NPV. So the first time you do an NPV, you have to do with the discount factor which is mentioned in the problem. Okay, definitely the problem will come with a percentage number. Okay, it will be there. So you have to use that as the discount factor. So now for the second time, if you use, okay, second time, you have to see how the number is. The number is a positive NPV. So as the NPV is positive, you have to again compute the NPV with a higher discount factor. So what we'll do, we have to again do the same sum, but this time we have to take a higher number. Okay, so how much higher should we take? See, that depends upon you. Okay, usually if you take something like 3, it would work well. Okay, just randomly put a number 3. Okay, you can just add 3. So we'll put like this: add 3% to discount factor. Okay, so we have got 13. So what we'll do is, with this we'll try to compute. So again, for the first year it is 1. From the second year it is previous year divided by 1 point discount factor. Discount factor is 13 this time. So let's get the answer. So it's 0.88. For all the years we'll put. We got the number. We will reduce the numbers after decimal to 3 numbers. I think this looks neat. Okay, we got all the numbers. Now, if you want, again you can check it with the table, present value table. So present value table, I'll just cut it and show you. So for 13%, for 5 years, these are the numbers we get. So just for showing you, I'll just put it here. So hope they are same. Okay, you can see it there. 0.885, 783, 693, 613 and 543. Okay, so you got the numbers. So I'll just remove it from here and I'll put it somewhere else. I'll put it here. So many students have a question like, how much of discount factor should I add? See, that's actually up to you. You can add between 3 to 5%. Okay, 3 to 5%. I have added 3. I think that is more than enough. Okay, we will get an answer. We will get an answer. That will not be a problem at all. So add between 3 to 5%. Okay, with the discount factor that you have got. Okay, so we'll get the answer now. The answer would be this number. So now we have to multiply, right? We have to multiply. So we have to multiply with what? You have to multiply not with this number. These numbers are discounted with 10%. Do not forget that. You have to multiply with the cash flow number. The cash flow into discount factor you have to multiply. The cash flow into discount factor you have to multiply. Students again make a mistake here. They wrongly multiply these two columns. So why do they do that? Because in the previous step they have multiplied these two columns and they have found out the DCF. This time they will multiply these two columns and they will put. That's a very wrong thing. You have to multiply the cash flow column with the new discount factor column. Okay, remember it well. So we will multiply for all the numbers. We've got all the numbers. We'll reduce the zero. Sorry, we will reduce the numbers after decimal. We will reduce. We'll get the new NPV. So now we get two NPVs, right? So NPV at 10% will be this number, right? It will be this number. And NPV for this number for 13% we have to compute. So we'll compute it as follows: 13%. So what's the total? The total is very simple. You can compute it in this way. See, typically the number will go to a lower number. Okay, why? Because there's another rule. Okay, there is another rule which says the discount factor and NPV are inversely related. Okay, the discount factor and the NPV are inversely related. This is a very important point. You have to remember that. It can also be asked in the theory questions also. So look at here. If your NPV is a lower number, if your discount factor is a lower number, your NPV is a higher number. If your discount factor is a higher number, your NPV will fall. Okay, so the higher and higher the discount factor goes, your NPV keeps falling. So if you want, I'll just check in Google Images the relationship between NPV and discount factor. Just 1 second, I will switch on the net. Okay. Okay, I think we got it. Okay, we got it. So let's see an image. The image will be a downward sloping curve. Let's see whether we have a chart or anything like that. Let's see whether we have a chart. Okay, I think there's only one chart here. So you can see here, as the NPV, as the discount factor is rising, okay, and this is the NPV, all the NPV. At the low discount factor, it is high. Just look at the dark brown line. As and when the uh, discount factor is rising, you can see the NPV falling. Okay, the NPV falling. Okay, so that's about the relationship between the two lines. If you want, I'll just copy the image and I'll put it lower so that you can refer it whenever you want. Okay, so we got this. So where is our IRR? That is the question. So we have still not computed the IRR. We have to get a formula. So this is the IRR formula. Let's first get the IRR formula here. So the IRR is L plus bracket NL divided by NL. Okay, once again. NL divided by bracket NL minus NH. Okay, all these things put together multiplied by higher versus higher minus lower. Okay, if you do this in Excel, it is going to be a little bit challenging because the brackets are the challenging. So how the brackets works, I will first you have to divide, you have to deduct these two numbers. Okay, then you will get a number in the denominator. Then numerator divided by denominator you have to do, and thereafter h minus l you have to do, and you will get now three numbers, right? The numerator, denominator, and here a multiplication. So all these three numbers you have to multiply, and finally you have done all this, you have to add with the l. Okay, so that when we do a sum, you will get much more clarity. Students usually struggle with IRR sums. Okay, but we'll ensure that you understand it perfectly. So we'll start from here. See, so NL is NPV at lower rate, NH is NPV at higher rate, H is higher rate, L is lower rate. So we have to get few numbers here. So we'll get the few numbers here. So we'll get L, H, then NL and NH. Okay, just four numbers we want. That's it. All the four numbers we have computed. So L refers to the lower discount factor. There are two discount factors. Which one is lower? 10. Just put the number 10. The higher discount factor is obviously 13. Okay. What is the NPV? What is the NPV at the lower discount factor? When you used the lower discount factor, what is the NPV here? NPV is 1086. Again, students sometimes do a wrong thing. They assume that the NL is the lowest NPV. Okay, the lowest NPV. So what they do is they take 274. That is a wrong approach. The right approach is first to start with the discount factor, which is the lowest. Okay, for that, what is the NPV? Okay, then you have to find out the NPV at a higher discount factor. This is the highest discount factor, and what is the NPV there? That is 274. That's it. So we just have to get our formula here. We can then start with the multiplication and stuff. So we'll remove the numbers. So L refers to what? 10. NL refers to what? 1086. Again, NL refers to what? 1086. NH refers to what? 274. H refers to 13. And L refers to 10. Okay, so done. So if I do this, I will quickly get the answer. Okay, I will directly get the answer, but I will show you a step-by-step approach also, right? I will show you a step-by-step approach. So So the answer, if you see, the answer comes to 14%. Okay, the answer comes to 14%. But see, the answer is a percentage. That is very, very, very important. The answer is the percentage. So I will remove the excess zeros, sorry, excess decimals. So you will get the answer perfectly. So usually you can put like after decimal, like at least 2 numbers you can put. That would be great. But here it is just 0.1. That's very, very negligible, but still we'll show it. Okay, but how do you solve this in an exam? Okay, with a paper. Okay, based upon a paper exam, how do you solve it? I will show you separately each step. So if you see here, 10% you have to add, so that you have it separately. Then you compute this part. You compute this part. Okay, I'll put that here. And thereafter you have one more part, which is this, which is the multiply 13 minus 10. Okay, that part. So if you see, there are 3 parts. Okay, there are 3 parts in this equation. So 10, the center part and the last part. So you'll solve each of it. The 10 you just bring it down. This part you try to solve it. So if you solve this part, it would become first we'll solve this, we'll get an answer. So that comes to 812. 812. And when we solve this part, it comes to multiplication of 3. Okay, so still we have one more part to solve. So we'll solve this. It comes to 1.33, like that. See, now first the multiplication has more value, so first that only you have to do. So the 10 actually comes again there. So this step would become 1.337. Okay, so that's what we computed. So 1.337 it has come. So it would again be 1.337 into 3. Okay, so again 10 will be there. Now solve this part. Solve this part. It comes to 4.011. Now add both. You will now get 14.01. So, and it's a percentage. So have you got this number exactly? Okay. So this number which we solved through Excel formula, we can also get it through this approach. Actually, Excel has an inbuilt formula also for IRR. I think it has. I'm not sure whether. Okay, it has, but we need some values, I think. Okay, we need some values. Then only we can find it out. I'm not sure how to enter the value. You can see some other video on Excel. So this is about the IRR. So what is IRR? See, IRR is a percentage. Okay, so we have to give a suggestion here. The suggestion is very important. See, as the IRR, now look at what is the discount factor. Discount factor is 10%. Okay, as the IRR is higher than the cost of capital, okay, comma, it is better to invest in the project, right? So this is an again important kind of a point. Okay, as the IRR is higher, it is 14%, it is higher than the cost of capital, which is 10%. It is better to invest. Okay, it is better to invest in this project. So we'll again now go to our discussion, like what is IRR? Okay, so we'll have another question. What is IRR? So IRR is the discount factor at which NPV equals to 0. So what does it mean? Okay, it means if you use the IRR as a discount factor, the NPV answer will become 0. Okay, so does it happen in reality? We'll check it. See, this is just a proof. Your answer is over. Your answer is over. What I'm now doing is just a proof to show you. You do not need to show this in an exam. Okay, so this is a proof. It is a proof not part of your answer. Okay, so that's like very important. So we'll start. So what is the IRR? So the IRR is 14%. At 14%, your NPV will become 0. So let's check. So the point is 1 point. If it's 10%, it is 1.1. If it's 14%, it is 1.14. That's it. So you have done for one year, copied and pasted for all the other years. So all of them will become the same number. Okay. So if you want, you can check with the discount, the present value table. So I'll just get the number so that it's easier for you. So look at here. So 0.877, 769, 675, 592 and 519. Okay. So that is about a 14%. So do we get our NPV to 0? Okay. Do we get it to 0? The answer is actually we are getting it to 23. Why it is not going to 0 then? Okay. See, it's not going to 0. I think it's because of some rounding here and there. Right? We have made some rounding here and there. So let's check. Okay. Because of the rounding we have made here and there, the answer is not coming here. See, the exact answer was 14.01. Okay. If you use the exact number, there's a high chance it will go to 0. Okay. Still it's not going to 0. See, I think you have to take more numbers here. Okay, I think if you take more numbers here or something, it can go. Or the exact answer here wasn't this 14.01, it was still some other number. So we don't need to think there a lot, but look here, it is moving towards 0. Okay, because earlier you had for 10% it was 1086, for 13% it was 274. Okay, so at 14% it will go towards the 0. Okay, so 14.01 or 02, it will go to 0, to NP will become 0. Okay, so you don't need to worry much about that. Okay, so I will remove that decimal part around. Okay, see, doing in Excel iteratively, it's quite easy. You can do it how many times you want, but doing it in paper, it's very complicated. Usually this is the kind of question they ask in BCom exam, MCom exam, ACCA exam. Okay, almost in all accounting and financial exams you will have IRR. Okay, because it's the challenging one and students miss out certain steps here and there and they'll get a wrong answer. Okay, that's the reason why IRR is like so frequently asked. So we'll do one more sum in IRR. So ZCO is considering a project which requires an investment of 1,40,000, has a scrap value of 10,000. The net estimated cash inflows are as follows. So we have 5 years and cash inflows are 40,000, 40,000, 30,000, 50,000 and 10,000. The cost of capital is 12%. Compute the following methods and suggest on the decisions to take. So we are working out IRR. So we'll continue with the IRR here. I'll just get the question data. So for this problem, we have to first do an NPV, then only we can do the IRR here. So NPV we have to do once with this cost of capital and first get an answer. So I have got the answer. Let's see. So we have got the answer from the NPV that we did earlier. So we got a negative NPV. So if we get a negative NPV, what we had a rule in the last sum. we'll follow the same rule. So the rule was, if the NPV is negative, so that's what we have here. If the NPV is negative, then again compute NPV with a lower discount factor. So we also had a rule that we can have a difference of 3%, okay, less discount factor by 3%. So we'll have that as a rule, and we'll move along. So we already had 12 here. So we'll use a lower discount factor. We'll use something like 9 and see what is the answer we get. And we'll also find out the DCF, and we'll also get the NPV. So this NPV is at 12% discount factor. We'll again find NPV for 9% discount factor. Okay, so we have to find out this. So as usual, it's going to be the first year discount factor is 1. Thereafter, it is going to be the above number divided by 1 point the discount factor. So discount factor is 9%. So we'll put it as 0.9. Okay. If it's 10%, we put it as 1.1. If it's 9%, we put it as 1.09. So we'll get the answer now. So we can copy the earlier cell and we can keep pasting it for all other cells. So this is the discount factor for 9%. We can also look at this through the table. So we'll get the table and we'll get an idea. So in the table, if you look, for the first 5 years at 9% discount factor, these are the numbers. So we'll reduce the numbers after the decimal. So 3 numbers after decimal is fine. So we'll just check the numbers now. So 917, 842, 772, 708 and 650. So we got our numbers. So now we have to multiply. See, we have to multiply the cash flow into the discount factor here. Okay, so we'll get the answer. So we got the answers now. So if you look here, we should not like multiply this number. Okay, we should not multiply this number and this number. Sometimes students do that. Okay, you should multiply the cash flow and the discount factor and get the DCF. So as you have done that, we can now get the NPV at 9%. So if you see, NPV at 9% is now positive. So the discount factor, sorry, the IRR is between these two numbers only. Okay, because IRR is the discount factor at which NPV becomes 0. Okay, so when NPV is 0, that discount factor is IRR. So IRR is definitely between 12% and 9%. So let's see what is going to be the answer. So we'll start with the formula here. So formula is IRR equals to lower discount factor plus NPV at lower discount factor divided by NPV at lower discount factor minus NPV at high discount factor into high discount factor minus lower discount factor. So this is the formula here. So we'll get the lower discount factor. The lower discount factor in this sum is 9%, and the NPV at the lower discount factor is this number. So it's going to be 1949, and the higher higher discount factor is 12%, and the NPV at the high discount factor is minus 7920. Okay, so that is the problem. We got these numbers, so let's put it in the formula and see how it works. So the lower discount factor is 9%. NPV at lower discount factor is 1949. Again, NPV at lower discount factor is 1949. NPV at high discount factor is minus 7920. See, there is a minus in the formula as well as there's a minus in the number that we computed. And again, high discount factor is 12 and low discount factor is 3. Okay, so if we solve it through Excel, if you want to solve it, if you're going to work this problem in Excel, you have to be very careful, because first this number has to be solved, then these numbers have to be solved. So to solve those first, you have to put a bracket here. Okay, so this indicates Excel that first solve this, then solve these brackets, and thereafter solve this bracket numbers, and finally you have one more bracketed number here. Okay, the outer brackets. So that's how the Excel will take this into account. So if we do through Excel, we'll directly get the answer now. We'll just try it. Let's see whether we get the answer. See, the answer comes to 10.7774. Okay, so let's do it as to how you will do this in an exam. So we'll start. IRR equals to so first keep this 9 plus separately. These inner components you have to do it separately. And you do this part separately. So I'll put it here. Okay, I'll put it here. I'll just ensure that these are visible. Okay, so it's a 3 part of the formula, 9 plus the central part and the last part. So we'll start each one. The 9 plus, just bring it down. This part we have to solve it. So to solve it, first we'll solve this element. Okay, this addition part. So to solve that addition part, first we'll start with here. See, the number comes to a positive number. Okay, because there are two negatives. Two negatives, when adding up, they become 9869, which is a positive number. Okay, so we got that part. So thereafter, this multiplication part would become this would be 12 minus 9, not this number. 12 minus 9 will be, so here also it will be 12 minus 9. Okay, we have done something wrong. Okay, so this will be the answer. Here it will be 12 minus 9. So when we solve this, it will become 12 minus 9 will become 3. So again, bring this number down. So now solve this part, you will get the answer. So the number that you get is 0.1974. Okay, again bring this number down. 9 again has to come down. So these two numbers have to be multiplied now. So let's multiply that, this number into 3. So that comes to 0.5922. So okay, so we got this answer. So finally we have to add both. So when you add both this and this put together, two components, our answer will be, okay, I think the 9 plus we have to remove. So we got the answer. So our answer is 9.592. So better I'll put a 9.59. Okay, I think that is enough. 9.59 or 9.6. We'll round it off to 9.6. The answer that you get is a percentage. Okay, the answer that you get is a percentage. So whether we compute it step by step or through directly through Excel, I think we are getting the same answer only, right? So whether this answer is correct, you can do a proof check, but in exam you don't need to do this step. So the proof check could be at IRR of 9.6%, the NPV will become 0. So let's check that whether it's correct or not. So let's check at 9.6% what happens. 0.96. So let's multiply and get the answer. So NPV at 9.6% would be okay. So we get a number like minus 118. Okay. So is it the right number or not? See, it is like closely coming to the number. So if you see, if we use 12%, it's like very high at minus 7920. At 9%, it is like 1949. But when we use a number like 9.6, okay, the difference is actually coming towards 0. See, this is like towards 0. So the number that we have computed is correct. Okay, the number that we have computed is correct. It's coming towards 0. See, exact 0 if you want, you have to put like full numbers. All these numbers, if you put, you'll get the answer. But we don't want to get an exact answer. No? We just want an approximate answer. I think that is more than fine. Okay. So we have got the answer now. So that's about the IRR. So we have to write a suggestion. So before the proof check, we have to write a suggestion. So suggestion would be so check the cost of capital and the IRR. Cost of capital is if your cost of capital itself is 12%, and the return that you are going to get from this project is only 9.6%. That is, the IRR is lower than the cost of capital, hence the project should be rejected. Okay, so rejected. That's about the concept here. Hope you guys got a good idea about how to work out an IRR problem. So we'll move on to the next type of problem, which is accounting rate of return.